Hello fellow problem solvers. So today we're going to be doing a problem from the International Math Olympiad Shortlist of 2014, problem number C2. This is a cool problem in combinatorics that I suggest you try out for a minimum of half an hour, ideally an hour and a half, but not more than 2.5 hours. This problem was actually on my first theme selection test for an international competition, and I did not solve this problem in the time allotted. But it's a very cool problem, and I suggest give it a go if you want to come and solve along with us for the next 10-15 minutes. Put your first ideas out on paper. And now, with that, let's begin. Reflecting a bit, I realized this is the first problem I'm going to show you that I actually encountered at a contest and didn't solve. But anyways, the thing is here, so you have 2 to the m sheets of paper, all have 1s written on them initially, and at every point somebody picks 2 of them and replaces the numbers. If those numbers have A and B on them, it replaces both A and B with A plus B on the 2 sheets. And the question is prove that after m times 2 to the m minus 1 steps, the sum of all the sheets will be at least 4 to the power of m. And this is, there's a couple of ways you can try to solve this. One is to think, when is this reached? And this is reached if you spend a little time on it, you'll see if you first make all the 1s a 2, then make all the 2s a 4. And all the way till you do this how many times? You do this m times, and that will give you this number, I believe. Yeah, if I'm not mistaken, that's how you get to the number 4 to the power of m, the sum of all the sheets on paper. And it then tells you, okay, maybe I should, do a greedy thing, try to prove a greedy algorithm works, and that is difficult. I'll say it's not impossible, it's difficult. But there's a different way of just approaching this given what's happening here. The question is what's happening on this problem? And the thing is, there is a change happening. And what's the principle once you see there's a change happening? You look for things that either don't change or change in a controllable manner. So you're looking at the sum. The sum, you really can't estimate the sum between 2 changes. This is the monovariant. You can't estimate that well, because how big are A and B, what kind are they, so on and so forth. So the sum's gone of all the numbers. If you're doing nothing weighted or anything, then it's just not going to work. So what else can you do? Well, here I invite you to pause for 10 minutes and try to figure it out. And the big idea is, one I did not get, is, mind you, I was a good competitor, so don't feel bad, is that the product here, if you look at the product at one turn, the product, without A and B, if that is, say, P, and then with A and B, it's P times A times B. And then after you do the switch, the entire product of all the numbers is P times A plus B squared. And now what do you know about these products? Well, you know that this product is 4 times as large, at least 4 times as large as this one. Why? Well, you cancel the p's out and you have a minus b squared is greater than or equal to 0, basically, because this is 2ab plus b squared plus a squared. This is 4ab, you put it up and you're done. And this tells you that, okay, so the product increases by 4, not increases, but is multiplied by 4 after every move. So the product at the beginning, before any moves, is, say, let's call this P1, is 1, right? And now what does the question say? The question says that we will be able to do moves, how many? After m times 2 to the m minus 1 steps. Okay, so this is maybe on the 0th step, it's 1. On the first step, it's exactly 4 in the first step. On the second step, it's greater than or equal to 4 squared. And so on and so forth. the product after the m times 2 to the m minus 1th step is greater than or equal to 4 to the power of m times 2 to the m minus 1. And now with this, can you estimate, if you know the product, can you estimate, and you know that it's bigger than or equal to this, can you estimate what the sum is greater than or equal to? Take 5 minutes and figure it out. And here's what the answer is. Well, the product, by using the arithmetic geometric mean inequality, this is the product of all the numbers, x1 through x, how many numbers? 2 to the power of m. Right? That's what it is. But this is going to be less than or equal to, so the sum of all of these, just call that s. How many numbers are there? S to the power, so it's going to be actually s over 2 to the power of m, and because it's how many numbers there are, to the power of 2 to the power of m. And now, what can you do with this? Well, take the 2 to the mth root on both sides, and what you get is that s over 2 to the power of m is greater than or equal to 4 to the m times 2m minus 1, and all of this to the power of 1 over 2 to the m. Now, how do these powers work? Well, you multiply things out and you get this as 4 to the m over 2, which is equal to 2 to the m, because 4 is 2 squared, to the m over 2 is equal to this. And so now with this, what do you get? You get that s is greater than or equal to 2 to the m times 2 to the m. Oh no, what is this? This is 2 to the m squared, which is equal to 4 to the m. And this solves your problem. You prove the problem by this. And honestly, I'll be frank about my experience here. Once I saw the solution, I felt so dumb and so stupid. How couldn't I come up with this? It was because I was looking at the greedy approach, maybe even induction. How can I, combine them? None of that worked. This is a solution. There is a greedy approach algorithm, but it's difficult. And at the very minimum here, what you've learned is you've further improved on your invariance principle. If there's a change happening, find something that doesn't change, or something that you can control. And especially with estimates like this, with these processes, this can be very useful. And this solves our problem, and as always, thanks for problem solving.